Derek, will you give us a quadratic function?
4x squared minus 2x plus 3.
That's Derek's function. Great job. Thank you very much. And we want to find f prime of a. How do we start? Lindsay, how do we start?
Would you start with f of x squared, or 4x squared minus 2x plus 3 as the f of x on the top of the, or I'm sorry, limit. Sorry.
Thank you very much. Good. So we will have 4x squared indeed, minus 2x plus 3, and minus Nabiha, minus Nabiha, are you with us?
Yeah, but I don't know.
Okay. Ian?
I don't know what FA would be in this situation either.
But we are following this. This is f of x. I already wrote x minus a in the denominator. What could this be?
4a squared minus 2a plus 3.
4a squared minus 2a plus 3, but with parentheses because negative 1 has to be distributed to all three. So I'm doing all this with the speed of moonwalk because I'm hoping you can follow. That's my hope. Okay, good. So then we have limit as x approaches a. And now I have 4x squared minus 2x and plus 3. And then, what do I need to write?
Minus 4a squared plus 2a minus 3.
Good. And luckily, at least something goes away. And now, let's plug it in. We know it's going to be 0 over 0. There is no question. So, when we discussed that situation with 0 over 0, what did we say? What is the culprit? What is the problem? What we are trying to get rid of so that the 0 over 0 goes away?
You need to find a factor.
Yes, awesome. Which factor is that? Great job. Which one?
A.
Say it again.
X minus a.
I'm so excited that I have to write excellent. Yes, the factor x minus a is the problem. This is the factor because it's x minus a. This is the factor that has to go away in order to remove the 0 over 0. Great job. By the remainder and the factor theorem. Excellent. Okay, so let's see how we do that. Who said this? Who told me that?
Person.
Thank you. Great job. So now you started to know me quite well. Good. So I have the limit as x approaches a. And what do? I already have that factor in the denominator. I love it. But what should I do to the numerator? How many terms we have in the numerator?
We have 4 terms in the numerator right now.
Good. Excellent. So what do you recommend? Look at those 4 terms and say, I think I would do this.
There might be some way to like group them and factor them.
Brilliant. Factoring by grouping, 4 terms. Great job. So I noticed that these two are quite nice. And of course, I'm looking for this factor. What will you factor out from these two? So you can get the x minus a. And thank you, Mark, by the way.
We could factor out the 2 after we rearrange it so that 2a and then minus 2x.
I don't want that. I want x minus a.
Well, if you rearrange it and then pull it out, that would be in the right order.
Good.
When you take the factor out.
So these two are accounted for. What do I do here? Anyone?
You could take out the 4.
Oh, very good. So that's our starting point. What is left in parentheses? Great job. Thank you, Mickey.
X squared minus A squared.
Good. What is the next step? Who would like to contribute now, please?
Would x minus a cancel out on the?
This is a part of a term. I cannot cancel out a part of a term with a factor. Please remember that. Actually, thank you for saying it so I can emphasize it. What is the next step?
We expand x squared minus a squared.
You mean?
The difference of two squares. So,
very good. So you meant to factor, not expand. Good. Awesome.
Right, yeah.
Excellent. Great job. How do we factor that?
X plus a times x minus a.
Excellent. What is next? Great job. Thank you. Was it Derek?
That was Josh.
Josh, thank you. Okay, what do we do next? Nabiha, would you like to try?
Now can you cancel?
Trey?
Factor out x minus a from both terms.
Brilliant, thank you. Now I can. Only now. Brilliant, thank you. What is left? In brackets. Lindsay, you want to try? Gia, you want to try? Anyone?
Yeah, it's going to be 4 times parenthesis x plus a minus 2.
Excellent. So final answer. Now I drop the limit operator. Isaac, do you want to try?
Is it going to be, we insert the a for the x's?
Absolutely. Brilliant, yes.
So it's going to be 4 times 2a minus 2.
Good. How much is 4 times 2a?
8a.
Minus 2. This is it. This is f prime of a. The rate of change of function f. This is the rate of change of function f evaluated at a. Great job. Okay, I have another problem for us that I copied. I think that this is much better. It's easier to see. So we are asked to arrange these numbers in order. 0, g prime of negative 2, g prime of 0, g prime of 2, and g prime of 4. What do they represent? So Oscar, can you tell us what do these represent? Any of these? G prime of negative 2 or 0 or 2 or 4. What do they represent?
The number you're going to be plugging into the derivative of the original formula.
Yes, that's fine. Perfect. But what is the meaning of it? Correct. Absolutely. But what is the meaning of g prime of negative 2? G prime of negative 2. What does it mean? Leonardo?
No.
That's the slope at negative 2.
Very good. So the rate of change of function g prime, sorry. of function g of x at x equals -2. That's exactly what it is. The instantaneous. The instantaneous rate of change of function g at x equals -2. Perfect. That's exactly what it means. Thank you. Who was that, Mickey?
Yes, that was me.
Thank you. Okay. So we have to determine these 4 values, including the 0 is 0, determine them, and we are asked to arrange them in increasing order. Okay. So g prime of -2. G prime, here's -2 right here. G prime, I'm going to draw a tangent. I'm going to estimate. I'm going to say 2 and 1. I'm going to give this a 2. G prime of 0. So here's 0. So here's g prime of 0. I will draw a tangent. I will estimate. I will say 1 and 1. I will give this a -1. G prime of 2. I will draw a tangent. I will say this is definitely higher than this. So that's why I gave this a 2. I'm going to give this one a 1/1. So I'm going to say that this is 1. Definitely less steep than this one. Here the slope is this, or the tangent is that, and here is the tangent. So this has to be steeper than this. The rate of change here of the function is higher than the rate of change here at 2. And now at 4, I'm going to draw a tangent, and I'm going to say 1 and 2. 1/2. Again, this is this slope. This is this slope. And this is this slope. So obviously this is the steepest. This is next. And this is next. So the most acute, less. So, and 0. 0 is 0. So now they want us to arrange them in an increasing order. So obviously -1 will be the first. So I'm going to say g prime of 0 is first. Then I will continue with 0. Then I will continue with 1/2. Oh, I meant to write the number. So, or I keep that. Okay, I'll keep, because I'm gonna scan this for you. So I either write g primes or I write numbers. I cannot do both. Okay, so g prime of 0 was the first, then 0, and now g prime of 4. And after g prime of 4, I will have g prime of 2. And the last one, g prime of -2. So 1, 2, 3, 4, 5. So that's how we estimate from the graph, as we did with the graph, of course, the same thing. Any questions on this? I'm going to put it through the notes after page 8. So I'm just going to do that right now, so I don't forget. So I'm going to call this page 9. Okay, any questions? Any questions? Okay, back to our sharing the screen and our text. So back to 2. That's all I had to say about chapter 2. And now let's see what else is interesting that we would like to look at from 2.7. The plan for Thursday is I'm going to post the previous test. Please finish up all WebAssign. WebAssign from chapter 2 has to be finished by Thursday. Please bring to class, like Mark did today, any questions you may have. That's number one. Number two, you will have a written, oh, nobody can see, right? Of course. My apologies. So you'll have a written work for Thursday. So all web assigned chapter 2, the written work for Thursday. And number 3, I will post an old test. And we are going to work in groups on this test, but I highly recommend you work on the test as much as possible immediately after I post it tonight, because I would like to use only 1 hour to review, unless you have questions, because I'm behind, like at least a week behind. Okay, so I will try to start chapter 3, but of course it's not going to be on our test. And number 4, test 1, a week from today, that's the 23rd. I'm looking at the calendar. So hopefully we can do this. If need be, I can postpone this to Thursday. I don't want to, but we'll see. Okay, so please remember these 4 items. Okay. For once, I didn't forget. Okay, so let's look at 2.7. We determined, I'd like to look at some word problems now. So this was the problem that I just showed a minute ago. I sent it to myself and I printed it out. Okay, so that's what you just saw. I would like to look at some word problems and some interpretations, because that's very important. Okay. I did put this problem before on a test. It's just a very simple situation. We are just asked to find the rate of change. How will I find the rate of change at this point? I will extend the red line and I will measure this height. I will extend it till the y-axis and I will extend it till this horizontal line. And I will determine this height. And I will determine this, the rise and the run. Obviously, it's a negative value. And that will be the derivative. The graph shows the temperature, okay? By measuring the slope of the tangent, estimate the rate of change of the temperature after an hour, which is right here after 60 minutes. So I will say rise, whatever I estimated, over run. Potentially 120. If I extend, it's probably about 120. So the rise will be, if this is, are they telling us what that is? Has reached 108 and placed on a table or room where the temperature is 75 Fahrenheit. Okay, so that's 75. So between 170 and 75, that will be the rise, and the run will be roughly 120. And that will be a negative number. It's decreasing. The function is decreasing, the slope is negative. Okay. Any questions? The 55 is just an overkill. We did this in section 2.1. It's the same thing. Exactly the same. Just you have a table and you follow the exact same steps. Okay. I wanted to determine, yes, 50. So let's continue with problem 50. Okay, age of t is the daily cost in dollars. So age of t in dollars. To heat an office building when the outside temperature is T degrees Fahrenheit. So T in degrees Fahrenheit. So what is the meaning of H prime of 58 and the units? And would you expect H prime of 58 to be positive or negative? Okay, so I'm going to stop sharing. Okay, so this is a function that presents the cost in dollars to heat a building. And this is the outside temperature. So what will h prime of 58 represent? Who would like to give it a try?
The total cost when the temperature outside is 58 degrees.
Excellent, thank you. Rate of change. Don't forget that. Rate of change. So whenever I see h prime, I always have to start with the words rate of change or instantaneous rate of change, which that's what this is. So the rate of change, or the instantaneous rate of change of cost to heat the building when temperature is 58 Fahrenheit. This is outside. Outside temperature is 58 degrees Fahrenheit. So what is the measurement unit? Remember the measurement unit. What did we say about the measurement unit of a rate of change?
It's time.
No.
It's a ratio.
It's a ratio.